Welcome back. In this video, we are going to solve a structural design problem that involves a one-way slab design using the working stress method based on eStructural Design Taichi found on the App Store. Design a reinforced concrete one-way slab using working stress method for residential use with 10 feet span and assumed thickness of 4 inches. Design criteria as follow. Strength of concrete 3000 psi. Main bars half-inch diameter bar grade 33. Temperature bars half-inch diameter bar grade 33. The first step in slab design is to determine the total load. The most common load combinations are dead load and live load. In this example, we assumed slab thickness of 4 inches, which translates to 50 pounds per foot. A live load for residential use is 40 pounds per foot, and an additional dead loads for floor finish and partition of 20 pounds per foot each gives us a total uniform load of 130 pounds per foot. Identify all input parameters required in our design problem. We name the slab as S1 with 10 feet span and 4 inches thick. A half-inch diameter bars grade 33 for both main and temperature bars. Strength of concrete is 3000 psi and a total load of 130 psf. Now solve the balance section properties given Fc prime equals 3000 psi and Fs equals 18,000 psi. After doing the calculations, we get N equals 9.289, K equals 0.411, J equals 0.863, and R equals 239. Proceed to flexure and slab thickness. With a total load of 130 pounds per foot and 10 feet span, the moment is equal to 19,500 inch-pounds. The effective depth is 2.61 inches. Add 1.2 inches concrete cover to get 3.81 inches slab thickness. We use 4 inches as minimum thickness of slab. We now solve the area of steel given M equals 19,500, Fs equals 18,000, J equals 0.863, and D equals 2.8. AS is equal to 0.45 square inch, and the spacing for half-inch diameter bar is 5.33 inches, round down to 5 inches. The area of steel for temperature bars is 0.096 square inch, and the spacing for half-inch diameter bar is 25 inches. Use 16 inches as maximum spacing. To test shear stress and bond stress, first solve for shear force, which equals to 650 pounds. Shear stress is equal to 19.35 psi, which is less than the capacity of concrete of 60.25 psi. For bond stress, solve the total circumference of a half-inch diameter bar spaced at 5 inches on a foot span, which gives us 3.77. This gives us a bond stress of 71.35 psi, which is less than the concrete capacity of 500 psi. The design results to our problem are as follows. Fc prime equals 3000 psi. Fs equals 18,000 psi. Length of span is 10 feet. Thickness is 4 inches. Main bars of grade 33. Half-inch diameter bar at 5 inches on center. Bent up alternate at L/4 plus extra top bars. Temperature bars of grade 33. Half-inch diameter bar at 16 inches on center. Thank you for watching. If you find this video helpful, please like, share, and subscribe to this channel.